So in this video, we're going to talk about the graphs of other trig functions. And the first one, we're going to talk about the graph of tangent x. So the period is pi for the graph of tangent x, and the domain is all real numbers except at the odd multiples of pi over 2, and the range is all real numbers, and we have vertical asymptotes at odd multiples of pi over 2. Now this is the graph of tangent x. Notice how we have asymptotes at the odd multiples of pi over 2. And keep in mind, this angle here is pi over 4. And we know the tangent of pi over 4 is 1. And this one here is negative pi over 4. And the tangent of negative pi over 4 is negative 1. Now, anytime I'm solving for the asymptotes, we need to put this quantity bx minus c between negative pi over 2 and pi over 2 to get the asymptotes. And then we can complete the pattern. So we have the graph of tangent x. Now if I want to draw the graph of tangent x plus pi over 4, so we have tangent x plus pi over 4, my graph will be moved pi over 4 to the left. So this is the graph of x plus pi over 4. So my graph got shifted pi over 4 to the left. Now in these exercises, we need to match the graph with the corresponding function. Now if I look at the first one, I see this one is the same graph as tangent x. So upon my options, it's going to be tangent x plus pi because the period of tangent is pi. If I look at number 2, I notice my graph got shifted pi over 2 to the left, so that's going to be tangent x plus pi over 2. Notice the asymptote that was at 3 pi over 2 now is at pi, so notice at the asymptote. So that's also another indication that my graph moved to the left pi over 2. So the asymptote that was at 3 pi over 2 now is at pi. Now let's do number 4 before number 3. I notice this one here is tangent x flipped about the x-axis, so that's going to be negative tangent x. Now this one here is, I see my graph, first of all, is flipped about the x-axis, and also it got moved to the right pi over 2. What used to happen at 0 now is happening at pi over 2. So the point that was occurring at 0 now is occurring at pi over 2. So my graph moved to the right pi over 2, and not only that, it's also flipped. So this one is going to be negative tangent x minus pi over 2. Now the graph of cotangent x, the period is pi and the domain all real numbers except for the integral multiples of pi. Notice the range is all real numbers. So we say integral multiples of pi because notice here the asymptotes occur at pi, at 2 pi, and keep in mind this is not the same as negative tangent x. Notice the asymptotes are between 0 and pi. So this is the graph of y equal cotangent x. Anytime I'm solving the asymptotes, I have to plug the bx minus c between 0 and pi and solving for. So now we have an example, y equal half cotangent pi over 2x. So now if I want to, the first thing I need to solve for the asymptotes. So we need to set pi over 2x between 0 and pi. And we need to solve for the asymptotes. So by multiplying to everything and dividing by pi, so we're going to get 0. So the asymptotes occur between 0 and 2. And yes, so this one is 0, 2, and we keep adding 2, and this one negative 2, and this one negative 4. So these are the asymptotes. Now we need to take few points to know how my graph looks like. So we have the asymptotes covered. We need to take few points and notice how by plugging 2 and negative 2 and 0 we get undefined because we have an asymptote. Now we're going to take few points, and if I took few points in the first period, I can continue these points. So the coordinates of these points I took are as such. I can keep adding 2 to the x coordinate. Notice 1 plus 2. Don't change the y coordinates, and we can complete the pattern. Now we have another graph, 3 cotangent x plus pi over 2. First, we need to calculate the asymptotes. So we're gonna write x plus pi over 2 between 0 and pi, and so for x. So that's where the asymptotes occur. Subtract pi over 2 from all sides. So the asymptotes occur between pi over 2 and negative pi over 2. So we're gonna have the domain all real numbers except for the odd multiples of pi over 2, and the range is negative infinity to infinity. Now we need few points. We're going to take few points so we can complete the pattern, and once we have the first one, so notice how the asymptotes occur at odd multiples of pi over 2. Now these points, we took them, and this point, keep in mind, is the one halfway between the asymptotes between pi over 2 and 3 pi over 2. Now the y coordinate for each point you take is not going to change. It's the point that we keep adding. So notice here, this point here is 4 pi over 2, that's 2 pi, 2 pi over 2, that's pi. So we keep adding pi all the way. Notice how this one is 2 pi, negative pi. So this one is pi, this one is 2 pi. So notice if we added pi here, so we have to add pi to find this point. We have to add pi to pi over 4 to find this point. Now the graph of cosecant x. So the period is 2 pi, the domain is all real numbers except integral multiples of pi. The range is from negative infinity to negative 1, union 1 to infinity. We have vertical asymptotes as integral pi's of pi. So keep in mind also the graph of cosecant x is an odd function, and odd functions have symmetry with respect to the origin. Now anytime we want to graph the graph of cosecant x, we need the graph of y of sine of x. And as can you see, as the x-intercepts, we draw asymptotes, and whenever I have a maximum or a minimum, we draw a parabola, and that's the graph of cosecant x. So let's see an example. So this is the graph of sine 2x plus pi, and we know how to draw the graph of sine 2x plus pi. Now if I want the cosecant 2x plus pi, that's the graph of cosecant 2x plus pi. Don't forget the asymptotes. So we had to use the first one to draw the other one. Now secant, we need the graph of cosine to draw the secant. The period is 2 pi and the domain is all real numbers except for odd multiples of pi over 2. The range is from negative infinity to negative 1, union 1, infinity. We have vertical asymptotes at odd multiples of pi over 2. And the secant function is an even function. So it has symmetry. It has symmetry with respect to the y-axis. So notice we need the graph of cosine to draw the graph of secant. For example, so this is the graph of 3 cosine 2x. If I want 3 secant 2x, so that's the graph of 3 secant 2x.